and then we'll go into polymorphism, and we'll look at abstract classes, and I'll cover some examples of where polymorphism can be used. But let's start with the virtual function. We've got a location class here. I'm going to use this, and it has a display method. And then we have the houseboat, which we would like to have given a display method that shows this stuff, and maybe shows this stuff as well. So let's do that. Let's write a display method here. Void display. So I'm overriding the display up in location, and I'll put some cout statements in here for the weight and the horsepower and all that stuff. What? You can't see it? Yeah, let me redo the land school. Did you get it? Does that work? Okay. So cout, we said horsepower, horsepower. Weight, rooms, and doors. So weight, doors, rooms. Now, I can call display against the houseboat, and which version do I get? Do I get the one I just wrote, or do I get the old one? Let's just see. Bummer. Still goes to the original. Is that what you expected? Okay, because these are just standard functions, and because this is a location pointer, I called it houseboat, and that might be confusing, but this is not a houseboat, this is location. Let's just change that. Maybe that will reduce some confusion. All right, I got a location pointer here called location. I have assigned it a location that is a houseboat, and then I call it display. But because it is a location pointer, it does go up here, and it runs the display function that belongs to the location class, because it's a location. Even though there is a display function down here in houseboat, and the pointer is pointing at a houseboat or location. It's a houseboat. It's pointing at a houseboat, so why isn't it running this one? And the cool thing is you can do this with a virtual function. If I make it virtual, it's going to consider the possibility that there is another version of this function further down the line. And it will go down here and check this out, and it will find this thing, and it will run this one instead. because it is pointing at a houseboat, even though it's a location pointer. And see, now we have display from houseboat, even though it's all garbage. I'm going to fix the garbage by adding an initialization list. I'm going to attempt to fix the garbage. I'll put a standard weight, standard horsepower, I run my program again. And I get all my default values. But the point is, sorry, I don't want to zoom out too much. The point is, it is calling this version because I made the base class version virtual. Now, if virtual just makes it really flexible. If I don't provide display for the subclass, in other words, what if I run display on the boat? What do I get now? Boat has no display function.
So it doesn't do it?
No, it will run the location version. Because a boat is a location, it will go up to location, it finds the simple version of display, and it will show me that. I'm going to comment that out so I don't run that constructor again, but let's just look at this. Okay, we got garbage, but it works. It went up to location, it did that, but if I do it on a houseboat, it's going to go to the houseboat and run that version. So that's what a virtual function does. Does that make sense? When a function is virtual, it's going to check in the derived classes and try to find a version that belongs to this specific object, even if it is a base class pointer. These could all be locations, right? And that's what I did right here. These are all location pointers. Why is this angry now? Oh, because I made them locations. Okay, never mind. Yeah, I'm not going to add them together. I'm just going to say equals new houseboat. All three location pointers. If I call it against house, what do I get? I'll get the location version. If I call it against boat, and if I call it against the houseboat, you get the houseboat because it is virtual. And so that's what a virtual function does. And you can see this work a little bit better. Now we'll dive into polymorphism here. I can have an array of location pointer. And I can set up a for loop and inside here, let's just get a random number and assign it to we'll do random numbers 0 through 2. And I can make a switch. And we'll say if it's a 0, location I will be a new house. Really should put the parentheses there, but you don't have to. And then in the case that it is a random number 1, locations I will be a new boat. And then in the other case, so what this is going to do, we're not even going to know what's in this array, but the polymorphism is going to work for us to call the correct version of the display function. And then we could use the same for loop, or we could do another one. And we'll call it display. So does anybody have any idea what the output's going to look like? It should be random. It should be different for all of us. Do you understand what the code's doing? We've got 10 pointers. They could be pointing at a house, they could be pointing at a boat, or they could be pointing at a houseboat. We're going to call display on all of them. If it's either one of these guys, we'll get the base version, and if it's the houseboat, we'll get the houseboat version. I'm going to put a C out here with an inline so that they're not all stacked up on top of each other. Now if we run that, no, I want to fix that. I don't want this anymore. I don't think we'll ever see this. No, we'll come back to it though, and we'll make it show up. All right, now this time. All right, so we got a houseboat, another houseboat, one of the other two houseboat. You know, you get different output, and it should be different for every computer, and it would be different every time you run the program if you randomize the timer. You seed it. But does that show you how a virtual function works? It just forces this call. When location receives a call to a virtual function, it's actually going to go check in the derived class and see if there's a better version or a more specific version that it should be calling. In Java, virtual is default. So if you don't want it checking your derived classes, you have to make this final or something like that. But in C++, virtual is not the default version. You actually have to say virtual. Most of the time your destructors need to be virtual. And why do you suppose that is? Well, we need them to use that one, but we don't want it to only use the base class destructor. If it only uses the base class constructor, then this memory down here doesn't get cleaned up. And that will lead to heap corruption. In a large program that runs in a loop where things are constantly being created and destroyed, if your destructors are not virtual and everything in the whole chain of inheritance isn't getting cleaned up, and you're only cleaning up the base class, you end up with heap corruption real quick. And whenever if you go over here to your project and you're like, I want to add a new class, it gives you the option here for a virtual destructor, because that's a pretty common thing. So when you're creating a class and you're going to derive from some base class, a virtual destructor is a good idea. All right, any questions on virtual functions? If I were to give you some classes similar to this right here and call a virtual function, you would know which version is going to be called. Or you would be able to look and see if it is virtual and then know which version is going to be called. And then the polymorphism is just the ability for this object to change into a house, into a boat, into a houseboat, and this function changes to whatever version is needed. That's the polymorphism. So what I would like to do next is a practical application of polymorphism. There's lots of places you can use it. It's really cool for just using arrays. In the game, you may have an array of objects that need to be drawn, right? Some of them they'll all be objects, and they'll all have a draw function, but it may be different. You may want certain blending on some. You may want some drawn with a different depth. But you shove them all in one giant draw list, a giant array of object pointers, and then you call draw on all of them. And the polymorphism will work to hop around to whichever draw function is needed for that specific object. And you don't have to say, hey, if it's an asteroid, draw it like this, or if it's a player, draw it like that. You don't have to put those if statements in there. All you have to do is call draw, and the language does it for you. That's what polymorphism is. That's the beauty of a real object-oriented programming language, like C++ or Java. So any questions on that? Let's take another break and then we'll come back and look at all right, so one practical application of polymorphism is a state machine, finite state machine. Anyone ever heard of that?
What machine?
Finite state machine. Okay, it's the idea of this machine or this program running in one or having multiple states but only running in one at a time. Okay, so one example I like to use is the calculator. This is a program that we use called a calculator. And when I move my mouse around, things happen. Different buttons light up. Different operations can be performed. But we also have a scientific calculator. Now, moving my mouse to the same place that it was a minute ago doesn't do the same things. That sounds really obvious, but if you're a programmer, you have to think about that. If I were to tell you to write a program with a scientific calculator and a standard calculator, and they have different layouts, you have to handle that. We can't be having the same thing happen in scientific mode that was happening a second ago in the standard mode, and then we also have programmer mode and some other modes, and so these are different states of the same program. Does that make sense? Everyone follow? Same program, different states. Another good one is video games, right? We start off on the main menu. That's a state. The controls, if you've got a controller in your hand, you're pushing left and right on the main menu. It does something different than it would in options or something different than it would during gameplay. You have different levels. All of these are different states of the same program. And so what polymorphism does, it allows you to set up your program to have multiple states, and it runs really efficiently. We're not going to run through a whole bunch of if statements that say, well, if I'm in standard mode and the mouse is at these coordinates, put a 7 there, turn it gray, and prepare to do standard operations. And then if it's in scientific mode, and then if it's in programmer mode, you see how the chain of if statements becomes just a giant staircase of mess? The more complicated your program gets, the more difficult it is to write if you take that approach. But you can bust it up into classes and then write only what that state needs and then make the program only run in that state. Then you have a little cue or a little switch or something that changes states, and when you change states, it only runs in that state. It keeps the states nice and clean. It keeps your program running really efficient because it's not worried about all the stuff in all the other states. It doesn't have to check any of that. It never even looks at it. It runs this state only, and then it checks for a switch. Do we need to change to something else? So that's a state machine. There's lots of applications for state machines, both in programming and in engineering. I've given you two here. A menu system is another one. AI, artificial intelligence for game agents, is written in state machines, or it can be. You can have a character that's patrolling. Another state would be to attack. Another state is dying, maybe respawning. Different animations, different behaviors, different ways it interacts with the game. And it allows you to, a state machine allows you to set up an agent and control it and keep its AI organized and very efficient. So there's a good application of polymorphism, and we're going to check that out. We're going to set up a menu system so we can hop around between different menus, just like I showed you with the, or different states, just like I showed you with the calculator. So let's say we're going to set up a base class, and we will call this I'm just going to call it state for now. That's probably bad because this could be for anything, but we'll say GameState. It's going to be an abstract class. We'll never actually create an object called GameState, but we will create a menu, a main menu. We will create options, and we'll create level 1 or something like that. But this will be the base class. Inside here, we're going to have, most state machines have a few different options or a few different functions, but they almost all have an enter. By the way, if we want this to work properly, it needs to be virtual void enter. And if you want it pure virtual, we set it equal to 0 in Visual Studio. In Visual Studio and GCC, this is a little bit different. It can be done differently. Enter is when you enter the state. This stuff only happens once. What's something that might happen in the enter function in a video game? Let's say I'm going from options back to the main menu. What would I do when I enter the main menu? It depends on the game or whatever, but you might want to queue up some music for that particular state. You may want to center the mouse on the screen. If you're starting up level 1, you may want to set the player's hit points to max and stuff like that. So this is some stuff that will only happen when you enter the state. That takes place here. Then we've got update, and this is where the meat is. This is where everything that happens while we are in this state. And then if we have an enter, we probably have an exit. So that will be where you kill the music or free up memory, free up some assets that you were using here in this state. You want to free up some memory. Those are some typical things that happen in the exit function. And we'll leave that for right now. But let's create some classes for our game state. We'll have main menu, and this will extend game state. And we'll have options. And I don't know, we can do level 1 or something like that. Do the man. Is this a good one?
Brand new. I can't tell you the other side of that. What they could afford.
Oh yeah, that's much better. Okay. So anyways, you would set up a class for every state in the program, for every game state. And we'll start with the main menu here. And each one of these we are going to be required to overload these functions. So I'm going to set a default constructor here I have to make this public. These should also be public. You could do this with structures too in modern C++. So there's a constructor, a destructor, and then our function. So we'll have void enter, void update, and void exit. And we just copy this, paste it, paste it. I'm probably going to have to come back and put delta in here eventually, but for now this will be okay. All right, let's see if this builds. All right, it works. If I take this out, still builds. I was expecting it to complain because I didn't override those functions there. Okay, for our inner function, we're going to do a simple cout statement that says, you know, we've entered this class. That lets us know what class we're in. So we'll do that for options, and we'll do that for level 1. And then update handles whatever goes on in this state. So if it's in the main menu, it's going to be looking for, it's going to be drawing some buttons or some state change options, things like that. Start new game, continue, exit. It's going to be drawing that stuff. It's going to be getting input from the user in this case. But update just runs everything that goes on inside of this state. And it also checks for a change to another state. So that's what we're going to do here. We're going to set up a way to change from one state to another. So what are our options? We're going to do it like a menu system. We'll have option 1, where can we go from main menu? Level 1. And options. And we'll get input. So we'll call it num cn num. And then we'll set up a switch. And we'll change states based on whatever they said. We'll come back to that. Well, let's do that for these other two. Just copy this and paste it. Paste it. All right, from options, where can we go? Can we go to level 1? In theory, you could go maybe out of level 1 and back into level 1, like in-game options. Some games let you access the options while you're playing. We're going to put it there just so we have two options here. We don't have just one, but there are some states where you would only have one, and that's fine. And so this will be main menu, and options. And if you wanted to, we could, put in an option to quit. For exit, we'll leave it empty for right now, but you could have, some statement in there saying you're leaving. Now what? Now we need, there's a couple ways of doing this. We need pointers. We're going to have a game state that is the current game state. And then we're going to need objects for each state that does exist. So we can instantiate these guys. And you don't have to call it a game state. And where would we start? Every state machine has a starting state, so yeah. We'll start at the main menu. I'm going to change this to main menu just to be consistent. These are all game states, so they can all be assigned to this pointer here. We could start anywhere. And then the state machine runs in a loop. And we're just going to current enter, current update, and then current exit. Although I don't think our exits do anything. But let's see if this even runs. All right, so our menu is fired up. It's waiting on our input here. Let's see if we can go to level 1. It failed. Oh, we didn't put that code in. Now I have to think of how I want to do this. All right, we'll do the quick and dirty method for the moment, and then we'll come back and refine it a little bit. Below GameState, but above everything else, GameState pointer, GameState, or sorry, current, main menu, options, and level 1. In order to change between states, these other states are going to have to be able to see these. So we're going to make them global. Another option is we could put them all in the base class, but we will have to reference them through the base class to do that. So we'll try it this way first. We'll do the global way, and then we'll come back and look at it a different way. Now I do not redeclare these guys. That would be bad. But we do instantiate them all down in main, and then that should work just fine. In our switch here, if they do press 1, current equals what? Level 1. Case 2, current equals options. And we're just swapping these pointers around. Case 3, exit 0. Why doesn't it like my exit 0? Oh, it's because I overloaded exit. I don't know. We'll come back to that. And we'll do the same thing for these others. Case 1, current equals main menu. And case 2, current equals level 1. So we're just going to switch states based on the user's input. Something failed. Now it works. Y'all's work? Okay, mine was being weird. Alright, now I should be able to go to level 1. Now it says entering level 1. That tells me that I am in the level 1 class. You don't want to think of it as a class, it's an object. But I'm working from this state of the program. I'm in the update of level 1. And from here I could go to options or I can go back to main menu, but I should be able to type those in. If I put a 1, I go back to main menu. I can put a 2 here, go to options, and from options I can put a 2 and go to level 1. I can go back to main menu, and then I could quit. Well, that broke it, but you get the idea. We're hopping around between these different states, and when this program is running, it's only running update for the current state. It's never looking at the other states. That makes it very efficient, and it makes it easy to organize. Now this is just simple cout statements, but in a game you'll have a main menu. On the main menu you're going to have a mouse, you're going to have buttons, you're going to be looking at input to hop around to the other states. In your level 1 you're going to be taking in user input to fly the spaceship, you're doing collision detection and keeping score and all that stuff. In options you're going to be adjusting volume and whatever else you do in options. But that's the code that would normally be in the update. Whatever that state does, you put in here. And then at the very end, you're checking for changes to a different state. Does that make sense? This is polymorphism working. We aren't telling it, hey, if I'm in, this is where our code runs right here. This is our main loop. We stay right here the whole time. We don't have to say, hey, if current equals main menu, then call this version of enter. It automatically knows. It automatically knows which update to run. That's polymorphism working for you. This is an abstract class. These are pure virtual functions. Is this class important? Do we have to have this?
Yes.
Have to.
Yes.
Has to be there because we need that base class pointer. You have to have a base class, you have to have inheritance before you can have polymorphism. So there's that. Now this global stuff, a lot of people frown on global variables, so I would like to move that into the main class here and keep it all contained. There's nothing wrong with this, but some people don't like it, so I'll show you a different way to do it. Are there any questions on what we have right now? Do you get the concept? Do you understand the code? Anything confusing?
What's the difference between a pure virtual function and just a regular virtual function?
Pure virtual, I believe pure virtual has to be.
I mean, aside from like the syntax, like function-wise.
I can't provide a definition for this in the base class. I think I have to provide a definition for it in the derived class. Let's see, if I take this out, let me see if my program still runs. No. It has to be, you have to provide, some implementation for a pure virtual function. So any class that is derived from GameState has to implement these three methods. They have to be there. Even if they don't do anything, you have to provide a definition for that. That's what the pure virtual does. It enforces it. That way my loop down here doesn't break. This is guaranteed to work. if they're pure virtual. Any other questions? Regular virtual means I do provide a definition here for the base class, kind of like draw. I can have a base class draw that just does the standard, like in SDL we could do standard render copy here, but if I want to do a render copy EX, or maybe put some blending on it, or something like that for certain objects, then I would have a virtual draw that works on most things, and then I would have, you know, a specific draw as needed. But it wouldn't be pure virtual, it would just be regular virtual. Pure virtual requires you to override it. And it also makes this guaranteed abstract class. I don't think I can create a GameState object now even if I want to. If I come down here and say GameState G, yeah, it flags it. It's like, no, you can't do that. Object of abstract class GameState is not allowed. So that enforces the abstract property whenever you make it pure virtual. Any other questions? All right, let's take 5. It's a 3-hour class. Run it for the long haul. Right? It's a 3-hour class, isn't it? We want to move these out of global space and try to get them contained in the class or in a class or something. What happens if I just do this? What sort of Pandora's box did I just open? Well, let's think about it. I had these in main originally, and we decided that wouldn't work because these classes can't see that, and I can't do this. Now, if I put them up here, can they see them? Yeah, they can see them because this is a parent class. They inherit all of these guys. What? So the syntax is okay, but is the program going to run? It's not. For one, it can't see them in main anymore. How could I fix this? Okay, I could initialize it in GameState, and that wouldn't be a bad thing. Could say GameState constructor, you know, current equals null. That could happen. Main menu, I can't create a main menu though because it can't see that. Can I use the scope resolution operator? There's another problem here. When I do this, each time I create a main menu, an options, or a level 1, all of these variables are created for each one of those objects. Does that work with our state machine? No, there can only be one current. There can only be one main menu and one options. What might fix that? Static. If we want something to only happen once, it needs to be static. Now that they're static, they'll have to be initialized. But But then I think I can reference them using scope resolution operator. And I'll have to do that down here as well. But now you see why I chose global, because it's a lot easier, even though it's a little unorthodox. This still isn't going to work though, I don't think. I think it's going to want these guys initialized in global space. Let's see if it runs. No. And we get an error for these static variables. Doesn't know what they are. So how do we initialize a static variable? Do y'all remember that? We have to put the data type, and then we put the class with the scope resolution operator and the variable name, and we set it equal to 0. And if we have to do that, there's no need for this. So it's copy, paste, paste, paste for each state. Main menu, options, and level 1. And in real C++, you don't have to do this in global space, but in Microsoft version, you have to. Now does it run? Hopefully. Oh my gosh, it runs. It even works. Oh, I totally did this on the fly. I didn't know if that would work or not. In theory, it should work, and it did, so that's awesome. But now this is contained. These variables belong to this class. All of the subclasses can see them, and then we can access them in main or wherever. Normally it wouldn't be main, it would be some other class with some other function. You can use the scope resolution operator to get to those static variables. How's that feel? Feels good, man? No? Then we'll add level 1, also from GameState. Alright, so now we're busted up. Everything's well organized. We just have to port all of this code over into the appropriate place. Let's start with the base class. I'm going to grab everything, including these static initializations, do a Control X, cut that out of there, and we'll move over into the header file and drop this guy down here. The only thing that's different is they have a constructor and a destructor, which is fine. So we'll delete that and uncomment all of this. And then I can put my constructor and destructor back in there. GameState, virtual GameState destructor. That should, oh, destructor gets tilde. That takes care of the base class. Maybe. We may want to move these over into the source file. I think sometimes it is done that way. We may have to do it that way. I take these and paste these over here. I think that is more proper. I don't know. We'll see if it works. We'll do the same thing with main menu. We'll go back to main. Grab all of this code. All the way down to options here. Do a Control X. And head over to the header file here and paste that in. We've already got GameState H included. And we'll uncomment all of this. And this is going to be a little more work. So we don't want to write our functions in the header file. We want to keep our functions in the source file. So let's do that. Void enter. Void update. And void exit. And we'll copy our functions and do a Control X and move over to the source file, paste these guys, and then I have to specify the scope. So I'm going to copy that and paste it in front of them, and that should make everything better. It doesn't recognize cout. How do I fix that? IOStream's not here, so let's go to GameState.h because it's included in all of these, and we'll put that up here. We'll say #include IOStream. No, it's highly frowned upon to put using namespace in a header file, but yeah, you need it. This can cause problems. But it will work. In our small little program that is only being worked on by us, this is fine. If you're working for a large company and a whole bunch of people using a whole bunch of different namespaces, you never put a namespace in a header file. This is happy now. Alright, so we've successfully ported 2 of the classes, at least in theory, hopefully. Let's continue. We'll grab options now. Control X. Paste it in there, remove the comments. Write our constructor, destructor, and our function declarations. And we'll take our code, our functions, cut those out, and move them over to the source file. And paste the scope in front of each function call, or each function definition, and that takes care of it. And one more time.
Ellie, it doesn't like my current in my main menu.
Where?
In my source files.
Doesn't like current or main menu? Do you have?
My identifier.
Hmm? All right, let's finish it and then we'll patch up the errors. Let's make sure this is going to work at all. I'll go around the room, help anybody that's stuck. We got level 1 left. But stick with this convention. We're going to move level 1 the same way. Main, I can't see any of this stuff, so we'll need to include. We don't need IOStream anymore. We're going to include GameState in quotes GameState .h include and then we'll include main menu.h level 1.h and options.h. Oh, I didn't make these declarations. I forgot to do that in main menu. But that should make it happy, hopefully. Oh, it says it's private? Oh yeah, these have to be public. All right, I think, yes, we're fully operational from multiple classes, multiple files. Who has questions?